Hello, everyone, and welcome to our fourth live presentation in our 2024 Adopt-a-Ship program. My name is Mitchell, and I'm a part of the Canadian Geographic Education team that's in Ottawa, Ontario, which is on the ancestral and unceded territory of the Algonquin people. Today, I am very excited because we have the amazing Tetjana Ross, who is joining us from beautiful British Columbia, and will be talking to us all about the science that happens in the oceans around Canada. But first, a couple friendly reminders before we dive into the presentation. First, please visit our website to watch any of the recordings if you didn't manage to catch any of the presentations live, we have them all on there so you can watch them whenever. Secondly, don't forget about the activity booklet and teacher's guides on our website, so you can follow along and do all kinds of lessons and activities that go along with the presentations, things that include signal flags, interpreting nautical charts, and even search and rescue operations. Next, make sure that you dedicate a little bit of time to brainstorm some ideas for our classroom contest that we have going on. And if you need to review any of the details, just check it out on our website or send us an email. And finally, our final presentation of the year will be with Commissioner of the Canadian Coast Guard, and we want you to ask questions to him. So if you go on our website, there's a place to submit questions, and you might just get your questions asked to the Commissioner himself. But back on to today, we have Tetjana Ross, who is a research scientist at Fisheries and Oceans Canada, to learn all about the important work being done by scientists to help monitor and help keep our oceans safe for people and for animals. And just a note, if we lose connection at any time, just give us a moment and we'll get Tetjana back if we lose any connection at any time. So thank you for being here, Tetjana, and I'll give it away to you.
Well, hello. Thanks for joining, and thanks so much for joining today, in particular because I had to cancel last week because I was sick. So, well, anyway, thanks so much. So I'm Tetjana Ross. So who am I? I'm a scientist, and I work for Fisheries and Oceans Canada. I'm also a mother, and I love to travel and sail and do stuff outdoors. I love to make things. Knitting is something I like to do quite a bit, but other things like origami and crafts. And I love to read and play with words and do word puzzles and things like that. So I just thought I'd let you know a bit about me as a human. I'm mostly going to talk about the science part today. And all right, I have one other slide about me as a human. I know that you're from all across Canada, so I thought I would let you know that I am also from all across Canada. I guess you can't live everywhere, but I grew up in Winnipeg. So here, right in the center of the country, and I lived there until I was a young adult, and then I moved to Victoria, and I went to the University of Victoria. That's where I did my PhD. Most people who work in science will have a higher degree. For me, it's a PhD. So you can call me Dr. Ross if you like, but I'm not a real doctor, medical doctor, just a scientist. And then I moved to Halifax, where I taught at Dalhousie University for 10 years. So I lived in Halifax there. That's where my daughter was born, and she lived there till she was 8. And then we moved back to Victoria when I joined Fisheries and Oceans Canada, and started working on the Coast Guard ships more regularly, although most Canadian oceanographers do work on these Coast Guard ships, even if they're not working for the government. So my connection to the Canadian Coast Guard, since you've been talking or hearing from a lot of people that are Coast Guard, Fisheries and Oceans Canada is kind of connected to Coast Guard, but it's a little bit separate. And so my main connection to the Coast Guard is working on ships. So this is a picture that I took, I guess, a year and a half ago or so, when I was working on the newest ship here on the West Coast, which is the Franklin, and or the Sir John Franklin. And yeah, so you can see I was excited by it because you could see the little doors opening and some of our oceanographic equipment coming out. But another thing that I do a lot, I interact a lot with Coast Guard and really rely on Coast Guard to deploy my oceanic robots. That's a big part of how I do my research is through using these robots. And then I guess you might be asking, like, why does Fisheries and Oceans Canada or Coast Guard, but it's more Fisheries and Oceans Canada, do science? So the main goal of Fisheries and Oceans Canada, or DFO, which is what we call it for short, is to protect and restore our oceans and coasts. And so science is needed for that because we need to have information in order to do that. How can you protect something that you don't know anything about? And how can you restore the oceans and coasts if you don't understand how what you're doing will change the ocean? So science is needed, I've listed here, to monitor changes in climate and its impact on aquatic ecosystems, to observe how the ocean is changing, and understand what is causing those changes, because then you can understand how you might make a change something about how humans are acting that would then affect the ocean. And then to determine what actions, like if we make a protected area, what kind of things do we need to do in that protected area to actually achieve the protection of the ocean or the animals living in the ocean, whatever it is that we care about most. So that's just a big picture about why DFO does science. But now I'm going to actually dig into a particular project that I worked on that I think you'll find interesting. So I'm going to come back to the robots, which are gliders. And then I'm going to ask this question: can gliders save whales? So we're talking about protection here, and we're talking about the science behind that protection. So first of all, I'm going to introduce to you what a glider is. So I've already mentioned that a glider is a robot. Let's see if this video will work. That would be nice if the video would work. Why is it not working? Well, it doesn't really matter. We can go ahead without it. So the video would have showed you how the glider operates, which is that it's in the water and it flies through the water. And what it does is it changes its weight. It makes itself heavier when it's at the surface by taking in water, so that it gets heavier than the water around it, and then it sinks to the bottom. And as it sinks down, it uses its wings to fly through the water. And then when it gets to the bottom, it has a little detector on it. So it sends out acoustic pulses, and it can detect when it gets to the bottom. And then it pushes that water back out and makes itself light and goes back up through the water. And that's how it moves through the water. And it can go for really long distances like that. And it carries sensors on it, and that's how we collect scientific data using it. Okay. It would have been nice if the video had played, but it's okay. So a question is why use gliders? Because people have been going out on boats and making observations of the ocean for hundreds of years. So why use these robots and not just go out and look ourselves? So one of the advantages of using gliders is that they can observe many different water properties. And when I say water properties, I mean things that you can observe about the water, like its temperature, how much salt is in it, salinity, chlorophyll. I don't know if you guys have studied this in school, but chlorophyll is the little bits inside the plant that can capture light and make them grow. So it's something that we observe in the ocean as well, because a lot of the plants in the ocean are actually tiny little algae that are mostly just chlorophyll and a few other things. And also oxygen, which is really important, that there's oxygen in the water, because fish and other animals need to breathe as well, just like us. And even sounds. So that's another kind of thing, and that ties into the question that I posed initially, which is, can gliders save whales? Because whales, as you may know, use sound a lot. Another advantage of using gliders is that they work 24 hours a day, 7 days a week. They just never get tired. They're not like humans in that way. They don't need to take a break. So that's an advantage of using them. And they can be out for up to a year. So again, who could you ask to work that long continuously? People would miss their families. And they can be out in any weather. Now, this is a really important one, because it can be dangerous to work at sea. So here's some pictures of this is a different of the Coast Guard ship. This is the Tully, another ship that I've worked on, and looking out into the stormy seas. And you can see how this is a big boat and it's getting knocked all around. So these boats do go out in seas like this, but if they're bigger but this is already, a bit scary for the people on board. And if it gets a lot worse, the ships can't go at all. So it takes heroes to work at sea in the winter. And we do have those, and they are part of the Coast Guard, but we can't ask people to do that all the time. And it's important to get data, scientific data, observations, even when there's storms, because different things are going on then. And if we really want to understand how it works, we need to get out in all weather, and the robots can do that. So why don't we just use robots? So they move really slowly and they can't fight strong currents, so you can't use them everywhere. They also can't bring anything back because of how they operate. They can't take any samples because it would make them heavier and then they couldn't fly anymore. So they can only collect data or observations. And they also can run into problems like fishing nets or plastic objects that, or they can collide with the sea floor, boats, animals, all of these things can damage them. And if they get hit and they burp out the air that's inside them and take on water, then they'll never be able to come up to the surface. So they're a little bit delicate. A storm doesn't bother them because they're underwater most of the time, and so they don't get impacted by it. And I have a kind of fun video that may work. Hopefully this one will work. It's weird that none of my videos are working. I wonder if I have some kind of weird setting on. This one's really fun. Oh, wow. Maybe it's better that we don't play it, because if there's some young kids in the audience, they might get scared. What this video shows is a shark biting the glider. So that's another thing that can happen to them. So you got to be careful if you're deploying them in shark infested waters. So this is just showing a bit more about the parts of a glider. I've already explained a bit about them. So they use these wings to fly through the water. They have an antenna. That's how they communicate with us. So every time they come up to the surface, they check in with us. So they connect via satellite. And then I also mentioned this part, the bladder that helps lift the glider up. And then usually underneath is where they have their sensors. So we have like an oxygen sensor, we have chlorophyll sensor, we have temperature and salinity sensors. And yeah, so I've mentioned that part. And then this is just showing you a bit on the inside. So they have two computers on board actually inside these parts here, and they carry lots and lots of batteries. That's how they can stay out so long. Yeah, and then the rudder helps steer them to go the direction they want to go. So I've spent a lot of time talking about gliders. Let's go back to, what about saving whales? Why have I not been talking about whales? So we're getting there, but I just wanted to talk about one more thing along the way. And here, maybe if you want, you could tell me what you think these two words means. Acoustical oceanography. Now, this is a really important part of how we use gliders to try and save whales. Does anybody out there know what this means?
We'll give classes a second here, but I'm guessing it probably doesn't mean anything about ocean animals playing instruments. So maybe something with the sounds in the ocean.
Yeah, that's right. Do you want me just to go ahead, or are the classes starting to come up with their own?
Yeah. You can go and I'll bring up anything if it comes up.
Okay. So first of all, oceanography. So I said I was an oceanographer at the beginning. I didn't actually introduce what that meant, but it just means the scientific study of the ocean. So, and then if we want to add on acoustics, so acoustical is just a modification of acoustics. So acoustics is the scientific study of sound. So if you can then put those two together, it's basically the using sound to study the ocean. So we have to understand the science of sound in order to then understand what's going on in the ocean. And so it's not this. It looks a bit more like this. So in here, we have a bunch of different things going on. Finally, there's a whale and there's a glider, both. And so basically what it is, it's the use of underwater sound to study the sea. So in the case of the gliders, it's got some kind of listening device on it. And so when it hears or sees, I used the word see in the slide, but and that's largely because that's kind of how whales use sound. They use it instead of sight underwater because light doesn't penetrate the ocean very well. So they use sound as a way of detecting or seeing everything underwater. But because they're sending out all of this sound all the time to detect their environment, if you just listen, you can hear or see a whale. And you can also do it from ships. So this is showing a bunch of different things that that glider, or sorry, that can listen or use sound in the ocean. So this is showing a little boat, and on this little boat, on this long end of this long pole is a tag, and people put those tags on whales, and they actually record the sound that the whales are making actually on the whale, but they also track where the whale goes. And then other boats both make sound that can impact whales, and they also can listen for whales, or they use sonar like whales to detect the environment. So the glider can listen, and then it can detect whales. And that's a big part of how gliders can help to save whales. So let's get into how the glider is helping it. So one of the big things, especially on the East Coast, when I used to work in Halifax, we talked about Atlantic right whales all the time. And there's a lot of protection that's going on because they're quite endangered. And they like to go pretty much exactly where the ships like to go. And they're slow moving, and they really aren't well adapted to get out of the way of ships. And so a lot of them are actually dying from ship strikes. So whales are in danger from ships. And so knowing where the whales, we kind of know where a lot of the ships are already because they carry a lot of technology on board, and they send out their positions via satellite and so on. But it's where the whales are that we don't know so well. So a great way to save whales is to actually let the ships know where they are. And so this picture shows a bit about how this works. So basically, the glider listens for whales, and then when it detects a whale, it knows that the whale has to be within some distance of it, and then it can communicate. When it comes up to the surface, it communicates to shore station, which then can give whale alerts to ships. And so that's a way that gliders can be just swimming out around in the ocean and help to save whales. And then, so a little bit about how the whale listening works. So basically, this is the nose of a glider. I've shown you several pictures of gliders already. And then we just put another little device on top, and it listens. And it's a smart device. So it listens, it records all of the sound, but it also has a little computer on board that detects when that sound looks like a whale call. So whales tend to make certain types of sounds. And so you can use a sort of library of whale sounds to detect a whale. And it's not perfect, but it works pretty well. And this is an example from a deployment of a glider off of the west coast of Vancouver Island, so not too far from me. I don't know if many of you know where Tofino is, but it's kind of halfway up Vancouver Island, maybe not quite halfway up, a third of the way up Vancouver Island. And it's a popular place where the Pacific Rim National Park is, and lots of tourists come. And so we deployed just north of Tofino, and the glider followed this black track here. And these pink stars are where whales were detected. And so, yeah, whales are detected, and that information is sent back to researchers in near real time. So within half an hour of hearing the whale, we would know about it. And then whale locations are posted online. An example is that whale app that I was just talking about that was tested a few years ago. And then, so the goal is to communicate whale locations directly to ships on the move so that they can take measures, either slow down or just avoid that location entirely. So I wanted to play a game, which is, would you make a good whale listening device? So I'm going to play you some sounds, and I'm going to ask you to guess what it is. And I want you to give two parts to it. First, just tell me whether it's a whale or not. And second, tell me what you think it actually is. So if you think it's a whale, what type of whale? If you think it's not a whale, what is it? So we did test the sound in advance, so I'm pretty sure that this is...
All right, I'm going to bring up our class that's joining us backstage here, and they can play this game along with you, if that's okay.
Excellent. Yeah, I'll play the sound again. I can definitely play them several times.
All right. Any guesses, Miss Bartlett's class, on what that first one was? I think you're muted there. Oh. Well, I can guess the first one. It was the first one. I think it wasn't a whale. I'm going to go with a boat.
You're
Oof.
right. It was a ship and not a whale. Hopefully we can get Mrs. Bartlett's class audio working, but I will play the next sound.
All right. You guys can put your answers in the chat as well if you'd like. Okay, so we have an answer for this one. Maybe glider sounds?
No, this one is North Atlantic right whale. This is one of the sounds that we're looking for. So yes, it is a whale. It was, they have this sound that sounds a little bit like a gunshot. Shall we keep going?
Yeah.
Here, I'll play it again because it seems like they might be having some technical difficulties. I'm just going to go forward and back because apparently I don't have the buttons to play things, but if I go forward and back, it plays.
That one's a tough one. I've heard that shrimp make a pretty weird noise. Maybe that's what that one was.
Is this when glacier falling? That's from the last one, or
okay.
I see something in the, but I wasn't sure whether that's for this one or not.
Yeah, I think that's for this one.
Okay, well, that's interesting. I often think it sounds a bit like frying bacon or something, but it's not. You're right, Mitchell. It is a shrimp. Ooh. So not a whale. All right, let's play the next one.
Hmm.
Should I play it again?
Oh yeah, let's get one more go.
Okay, here we go.
So Miss Bartlett's class thinks that could be a glider. I think that's something living. I'm gonna go a whale, but I have absolutely no guess as to what kind of whale.
All right, you're right. It is a whale.
Nice.
It's a gray whale. All right, let's go on to the next one.
Hmm. Miss Bartlett's class thinks that one's a whale. Does Brandy Bassett's class have a guess for this one? I'll go orca for that one. And then Miss Brandy Bassett's class has a glider going down into the water.
Oh, it's actually lightning. It's a lightning strike on the surface of the water. It does sound quite a bit like the whale sound from earlier, though, so I could see how it would be deceptive. All right, let's keep going.
It's a pretty iconic one. I'll have to go with a dolphin on that one. Or wait, dolphin adjacent, maybe an orca. Maybe that one's the orca. Anyone else? Miss Bartlett's class says dolphin.
Yeah.
All right. What was that? And Brandy Bass's class says orca as well. Nice.
Yeah, you're right. It's an orca or a killer whale. So, yes, whale.
I think I remember what this one is, so I won't guess. But
okay. Anyone else want to guess?
It's a tricky one.
A boat. I see a boat as the guess.
All right.
Is there another guess from another class?
They both say boat for this one.
Oh, well. Then you're going to be surprised to hear that this is actually also an orca. So this is kind of an interesting story. The other one, the iconic orca sound, is sort of a communication call, how they talk to each other, sounds that they make. We don't know exactly what they're saying, whether it's language or not. But then this sound is the sound that they make to detect their environment. So that kind of like bats, they send out these clicks and then they listen back and then they can see how far things are away. And the reason why they were changing so much was that that was recorded during a time when an orca was investigating a new object. So I wasn't on the boat when it was collected or anything, but the researchers had put in the water a glow stick, just trailing it on a string, and the orca didn't know what it was, and so it was coming to investigate it. And one of the things that have been observed about how they use their echolocation is that as they get closer to an unfamiliar object or something that they're interested in, they start to go much, much faster, so that they get more information that way more quickly. And so, those were both orcas, but they were using sound for different purposes, so they sound quite different. All right, let's keep going. I've got more. Oh, right. My next thing, of course, it was a whale, but my next thing is actually just to suggest something that you could try in your classes if you want. So you can play a little game that where you can try and do echolocation yourself. So you can set up a little a little apparatus, I guess, a little experimental apparatus that looks a bit like this. So one of the pieces, so down here, I've given the worksheet that can be found here. And it suggests, because it's an older bit of, I don't know, an older worksheet, it suggests putting like a watch or buzzer in there. But one of the really great modern alternatives that works actually better than a little ticking thing is to put earbuds. So if you attach your earbuds to your phone and you play a metronome, then you can really bury the earbuds inside the tube so that it makes it harder to hear it across here. You can only hear it through the tube. And then you can put different materials there. I definitely recommend, if you try this, that you bring something like a cookie sheet as your reference, because you'll definitely hear it off the cookie sheet. The cookie sheet is a really good reflector, but then you can compare that to a bunch of other kinds of objects that you put in this in the place of the board, and then you can kind of like hear the difference between them and you know, try out your own echolocation. Anyhow, now I do have more sounds. I'll play it again.
Let's go with a right whale on that one. I'm not sure if we already had one or not, but
okay. I see whale from Mrs. Bartlett's class as well. Is there another one?
Yep. Miss Brandy Bassett's class has whale dolphin.
Okay. So you're right. It is a whale. It's beluga whales, which are related to dolphins, but both belugas and orcas are kind of quite related to porpoises and dolphins. They're toothed whales, right? Unlike the sperm whale or the right whale, which are baleen whales. So they're quite different evolutionarily. And these guys are known for their diverse and frequent vocalizations and have been given the nickname sea canaries, which I thought was an interesting fact about that. All right, let's go on to the next one. Any guesses?
Maybe like a sea urchin or something like that. Some bottom feeder.
Yeah, it does sound kind of like a scraping sound, doesn't it? A crab, I see.
Okay.
And I can only see Mrs. Bartlett's class for some reason, so you'll have to.
Yeah. And then Miss Bassett's class has a crab as well.
Okay, cool.
With crab.
Well, it's a sea urchin, so you're all right that it's not a whale, and it is something that's along the bottom, but it is a sea urchin. All right, let's go. We have, I think this might be the last one. Is it a whale? I'll play it again.
We have Bassett's class has a whale, and Miss Bartlett's class has a glider.
Well, it is a whale. Yeah, it's a
fin whale.
Yeah, it's a fin whale. Yeah, they get to be really big. They're not the biggest, but they get to be 80 feet in length or 24 meters. So they're huge. All right. Well, thanks for playing that with me. And I noticed that many of you guessed glider, and gliders are actually really quiet, which is why you can record the sound off of them. So yeah, they're kind of boring to listen to. Which is why I don't have any glider sounds in this presentation. Anyway, I just thought I would end with like, what's next with this research? So So people are continuing to work on this whale observation thing, but that's actually not what I'm actively working on anymore. So what I've been working on is more on the oceanography side. So of course, when these gliders were collecting the whale observations, they were also collecting oceanographic data, and we did use that to try and understand if there was a relationship between where the whales were, or in particular, we were thinking about a location off of Nova Scotia, and like that is a regular feeding place for whales, but they don't come every year. So maybe like 5 or 6 out of every 10 years they're there, but not every year. And so we were trying to understand a bit about when they're there and when they're not, and what oceanographic conditions affected that. But now I'm doing mostly just ocean conditions and trying to understand how like temperature and oxygen is a big one, and also ocean acidification, how these things are changing on our coasts. And so these are all the different glider tracks from the last 4 years, I think. And so we do regularly go out along this line, which goes quite deep into the Pacific Ocean. And we also fairly regularly encounter these big features, which are called eddies, where the like temperature will be quite a bit warmer than the surrounding ocean, and there usually is more plant like chlorophyll, so there's more phytoplankton growth in it, and so then that's when our gliders do these cross shapes, because they go investigate the eddies. And then we also are doing this sampling here, which is across Queen Charlotte Sound, which is a really underobserved part of the BC coast. We tend to know a lot more about what goes on down here in the parts where more people live. So the gliders, Queen Charlotte Sound is pretty famous as being quite a rough place to work. So the gliders are really helping to provide more information. And there's some important marine protected areas here that we go along beside. So that's what we're working on now. And there's the website down there if you want to have a look at our deployments. And this is where our gliders are actually right now. These 2 pictures on there. This I took a screenshot just this morning.
Well, awesome. Thank you very much for all that. That was amazing. And we'll try and get some questions here. We'll try Miss Bartlett's class's mic one more time, but if Miss Bassett's class has any questions they want to put in the chat or not, we can take those now, and we'll try Miss Bartlett's class.
I'll stop sharing my screen so that it's more, so we're bigger.
Oh, we still can't hear. All right, well, if you just want to put your questions in the chat, that's fine too.
Yeah, I see the mute is on. Okay. It shows it in the corner there.
How fast can the gliders go?
So the gliders are pretty slow. They travel at about 1 kilometer an hour, which is slower than you walk.
And you said that they can go be out in the ocean for a year?
Yeah, we don't usually send them out that long. I think our longest deployment was about 4 months, but maybe 4.5 months. But other people have sent them out for over a year. We like to collect a lot of data when we have the gliders in the water, and that costs energy. It's always a balance between, how fast you go, how much you're sampling, and how long you can go for. So we choose to go a bit faster and collect more, but change them more frequently. Right. So how much do the gliders cost? They're quite expensive. They're about $250,000. So I used to say they cost similar to a house, but that's not true anymore. Now houses cost so much more. Anyhow, a few of them cost a house. And how could they be improved in the future? Well, the kinds of things that people are working on is to make them go deeper. Right now, they go through the upper kilometer of the ocean, but the ocean is on average about 4 kilometers deep. So they're definitely not sampling the whole ocean. That's one thing that people are working on. And another thing that people are always working on is improving their sort of how much energy that they can carry, how much they can do. So new sensors and new battery packs that allow them to go longer or collect more information. One of the things that I would really like to do with our gliders is to put pH sensors on them. I had talked about ocean acidification, and right now we can measure things that are related to ocean acidification, but we're not actually measuring the acidification itself because we don't have that technology available to put on gliders. How often do they find whales? Well, it depends on where they are. So when you put them out in a place where you expect there to be whales, they usually find them pretty fast and regularly. Like they find them several times a day. But if you put them out in other places, we've had some missions where they only found a whale every week or something like that.
All right, so we have 2 more, and then I think we'll
When
try.
was the first glider made? Sometime in the 1990s. But I did not make the first glider. And do the gliders go into the Arctic too? Yes, they do. The ice cover is a bit of an issue there, right? Because gliders need to come up to the surface to communicate, so and to know where they are, right? So they get pushed around by currents because, as I mentioned, they move pretty slowly. But if they can regularly check where they are, they can account for that and keep going to the right location. But if they're under the ice, that gets a bit harder. So some people have done things, but it's a lot more expensive to do this, so it doesn't get done that often. But where they use sound to help them locate where they are under the ice. So yes, they do go to the Arctic too, but not as regularly.
All right, well, thank you very much. And thank you very much to all the classes that asked some questions. And I think we'll try and wrap it up there. So thank you again, Tetjana, for coming and talking to everyone.
Yeah.
And thank you for all the great questions. And,
I like seeing all those faces and waves. So thanks so much.
Okay.